All right, so really the only new lesson notes today are what's in bold here. So the equation of a circle that's centered at the origin is going to be in this form: x squared plus y squared equals r squared. The only thing that will change is the radius. However, when we have a unit circle, we know that the the radius is 1. So the equation of the unit circle is x squared plus y squared equals 1. And by doing that, we actually lead to this really important formula called the Pythagorean identity. The Pythagorean identity. Okay. Um, if I know that the equation of the unit circle is x squared plus y squared equals 1, I know on a unit circle, I know that x goes with cosine and y goes with sine. So if I plug in cosine for x and sine for y, I end up with cosine of a squared plus sine of a squared equals 1. That, again, is known as the Pythagorean identity. Okay. With that in mind, let's take a look at the examples here. We have 4 of them. Okay. The x-coordinate of a point on the unit circle is 3/5. Okay. If you're wondering, 3/5 is approximately equal to 0.6 as a decimal. What does this tell you of where that point might lie on the unit circle? Find any possible y-coordinates of the point and plot them on the unit circle. So here we have a unit circle. Okay. X, remember, is your horizontal. So here is where x is 0. Out here is where x is 1. So x is going to be 0.6 somewhere in here. Okay, so that's going to be where 0.6 is. Okay, now based on the circle, there could be 2 possible y values. Okay, I could have a y value up here, or I could have a y value down here. So to figure out those 2 possible y values, I'm basically going to create 2 right triangles, and I'm going to use the Pythagorean theorem. Okay, so I'm going to use this top. So in this right top triangle, I know that this is 0.6 because that's the x value. I know I'm looking for my y value, and I know that my hypotenuse in this case is the same as the radius. And because it's a unit circle, I know that the radius is 1. So if I use the Pythagorean theorem, and I do my a squared plus b squared equals c squared, I know because the hypotenuse is 1, I know that that has to be c, and I know that this has to be either a or b. So we've done examples like this before. All right, so if we simplify that, okay, so 0.6 squared, so that's 0.6 times 0.6 is going to be 0.36, and 1 squared is 1. So I'm going to solve this by subtracting 0.36 from both sides. Okay. And I end up with a squared equals 1 minus 0.36. And I'm just using the calculator on my phone, which is 0.64. Okay. And to find my a, I'm going to simply square root both sides. Okay. Now, here's where it gets interesting. Okay, we know when I square root, the square root could either be positive or negative. In this case, I have a y value that could either be positive or negative. So I'm going to have to do the plus and minus here. And if I go to Desmos, I can go ahead and I can find the square root of 0.64, and I end up with 0.8. So my two possible y values are positive and negative 0.8. And again, how did I do that? I used the Pythagorean theorem. So my two possible y values, the answer to number 1 is plus positive and negative 0.8. Okay. Number 2, the y-coordinate of a point on the unit circle is negative 0.4. What does this tell you about where the point might lie on the unit circle? Find any possible x-coordinates of the point and plot them on the unit circle. So hopefully you got this down. For now, I'm going to erase this so I can get a fresh diagram. Okay. So if I redraw the unit circle, okay, I know. So that's 1, 0, that's 0, 1, that's negative 1, 0, and that's 0, negative 1. So I know that my y value is negative 0.4. So negative 0.4 as a y value, okay, if this is 0 and this is negative 1, then negative 0.4 is going to be somewhere in the middle, okay? And because of that, I know that I could have one of two possible x values. I could have one over here, and I can have one over here. It's the same as I did before. So I know that this is negative 0.4. Okay. If I draw the hypotenuse and make the right triangles again, I know that the hypotenuse is 1. So I'm literally going to do the same thing I did before, except now I'm figuring out what my possible x values are. So when I do my a squared plus b squared equals c squared, again, my c is going to be 1 since that's the hypotenuse. Okay. I'm going to make my b negative 0.4 squared. So I have a squared plus negative 0.4 squared equals 1 squared. So if I'm going to, on my phone, I'm going to do negative 0.4 squared. So negative 0.4 times negative 0.4. And I end up with 0.16. And obviously 1 squared is 1. All right, I'm going to subtract 0.16 from both sides. Okay. 1 minus 0.16 is 0.84. And then just like I did in the previous problem, I'm going to take the square root of both sides. And because there's two possible x values, I have to do the plus and minus. So a is going to be plus and minus. Let's go to Desmos and let's do the square root of 0.84. And that's going to be plus and minus. We're going to round that to 0.92. Okay, so the answer to number 2, okay, find any possible x coordinates. The possible x coordinates are positive 0.92 and negative 0.92. Okay. Number 3, a point A on the unit circle makes an angle with the positive x-axis whose measure A satisfies sine of A equals 0.9. Sine of A equals 0.9. Which quadrant could A be in? For each possibility, find cosine of A. So the key in this case is that sine is positive. Sine is positive. If we go back and we look at our lesson notes, Okay, sine can be positive in quadrant 1 and quadrant 2. So the first part of the question is, which quadrant could A be in? It could be in quadrant 1 or quadrant 2. For each possibility, find cosine of A. Okay, so we're going to end up doing the exact same thing. So let me erase this again so I can get a fresh unit circle in here. All right, and I'm going to redraw the unit circle. Okay, and the key is that sine of A is 0.9. Okay, and I know with a unit circle, sine goes with y. So this is really telling me what the y value is 0.9. That the y value is 0.9. So I'm literally going to do the exact same thing I did before, because by using the Pythagorean theorem, I'm going to figure out the x value, and I know that the x goes with cosine. So let's go ahead and do that again. So I'm going to do my a squared plus b squared equals c squared. I know that my c has to be 1 because it's a unit circle. I know I'm going to make b 0.9 squared. All right, and I'm going to do the same thing I've been doing. So 0.9 squared is going to be 0.81. That's going to be 1. I'm going to subtract 0.81 from both sides. So 1 minus 0.81 is 0.19. So a squared equals 0.19. So I'm going to square root both sides, and I end up with a equals, let's go to Desmos, and let's do the square root of 0.19. So it's going to be plus and minus 0.44 if I round it. Okay, so cosine of A, so we figured out that the x value is 0.44, and the x value is the same as the cosine. So for each possibility, find cosine of A. It's either going to be positive or negative 0.44.